All right, we're going to look at translating the graph of sine and cosine. Yesterday we talked about stretching horizontally or stretching vertically. Today we're going to look at translating, moving. So here we have something from yesterday. We have a function y is equal to 3 cos of 2x. What are the transformations that have been applied to this to get to the graph of y is equal to cos x? What have I done to the graph? Ashley, you give me one?
So vertical stretch,
vertical stretch is 3 in the x-axis. And what's the second one, Chloe? Horizontal stretch by a half. So which parts of the graph, or what are the things that we called basically period, domain, range, and period, domain, range, amplitude, and x-intercepts? Which one of these would have affected the x-intercepts of the graph? Aaron? Would the vertical stretch affect the x-intercepts or the horizontal stretch? The horizontal stretch is going to affect the x-intercept. Because I have taken the graph that went like this, and now I have taken the graph and like that. Okay, so my x-intercepts are changed by my horizontal stretch. What other thing has been changed by my horizontal stretch? What other of those ones we talked about? Domain, range, period, and amplitude. Which is affecting the horizontal, or affected by the horizontal stretch? A period. Okay? Because the period was originally 2 pi, we horizontally stretched it by a factor of a half. The period is now pi. So here are the x-intercepts of this graph. The x-intercepts of y is equal to cos x are pi over 2 and 3 pi over 2. And 5 pi over 2 and 7 pi over 2 and 9 pi over 2 and so forth. Okay. The new x-intercepts are pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. These are, because we've taken these guys and moved them each 1/2 times as close to the x-axis. Now, what is an equation that we could get to write, what are an equation or equations and it's sometimes easier to see this on a, okay, easier to see that there. What equation? Well, if we look at this, we have pi over 4, pi over 4, pi over 4, and so we could use pi over 4 plus 2 pi n, and 3 pi over 4 plus 2 pi n, and so forth. But with this one, you can see that guy is 2 pi over 4 units to the next guy, or pi over 2 units. This one is 2 pi over 4, again, pi over 2 units to the next one. This one is pi over 2 units to the next one. And this guy is pi over 2 units. So for this one, by looking at it visually, we can see that one equation, the x-intercepts are described by pi over 4 plus pi over 2 n. Now these are not coterminal angles. This is just an equation that is used to describe all of the x-intercepts for this function, and well, not only this function, but it's not going to show up very often. Because if I was a cosine x, my solutions would be pi over, well, it would be pi over 2 plus pi n, because it's here and here are our solutions. Okay, so we can do it, but we have to look through it in a visual format. Okay, so now let's take a thing. If I start to go, if I want to look at a new equation, or what do C and D do to our function, going back to what we have here?
C will move it left and right as long as it can.
Terminology, we have a horizontal translation for C, and we have a vertical translation for D. So those are perfectly, what you said was fine. And I'm perfectly happy using horizontal and vertical translation. But being complicated like we are, we introduce some new terminology to here. We talk about a phase shift when we talk about sine and cosine or sinusoidal functions, and we are talking about a vertical displacement. Now, if you don't use those terms, I don't have a problem with that when you're doing written response, but you do need to know those terms. Sorry for the writing, that's terrible. You need to know those terms when we're reading questions. Okay. If you describe it, yes, I move this graph 30 degrees to the left, you're perfectly right. We could also call that a phase shift of 30 degrees left. Now the reason why we call it phase shift is when we look at sinusoidal graphs, they're kind of out of phase with each other. And we use a lot of sinusoidal graphs in electromagnetic radiation, radio waves, etc. And other sound waves occasionally follow that same pattern, etc. So, would changing C, so we're picking the graph up and we're moving it left and right, would it have any effect on the domain? Oh, the domain is all real numbers? No, picking up, moving, it ain't going to change it. Will it affect the range? No, range is a vertical. Range is this way. So if I pick it up and move it up, yes. My x-intercepts, it will change. Because we've got our x-intercepts from our stretch graph, then we pick that graph up and we move it pi over 2 units left or pi over 2 units right. Changing D, well, domain will never change, right? Because the domain is all real numbers, can't change that. Taking the graph and moving it up or down, is that going to affect the range? Yes, it will affect the range. It will also affect the x-intercepts, although not on a predictable pattern. Because if you give me the x-intercepts and you then apply a phase shift like up here, oh, every x-intercept is now pi over 2 units to the right, depending on what we have. This guy here, I'm picking the graph up, so I could have, here's my original graph, I could have my new graph here. Well, it's not going to work, is it? There's my original graph. If I shift it up, I could have, there's my x-intercepts there. They're hard to find because it's being shifted up. I could do it with an equation, but not so much with predictability. So please use graphing technology to sketch y is equal to sine x minus 30 degrees plus 3. When you do this, make sure your calculator is in degrees and then go zoom trig. That way you get this all the time. Now, here's the thing. If I just do the graph and I just hit zoom 6, I get something that looks okay in this case. Although I'm not sure why. Well, I know why, because notice my mode is still in radian mode. Now if I graph it, I get a straight line. So I change my mode to degrees, and then I'm going to do zoom 7. Or I'm not, yeah. Okay. So we have this graph. The domain of that graph. Sean? What's the domain of this graph? The domain is all real numbers. Graph. That's terrible. The domain, as I said, is all real numbers. The range. The highest point on my graph is 4, and my lowest point is 2. So my range is from 2 to 4. And if we look at our parameters here, A is equal to 1, B is equal to 1, C is equal to a positive 30, and D is equal to 3. Which parameters have an effect on the range? A, B, C, or D, or multiples of those? Does D have an effect on range, Rory? Yeah. Would C have an effect on range? No. Would B? Moving in and out. Now, A in this case is 1. But if A is 2, is that going to change the range? So we have 2 parameters. We have range and vertical displacement. not range, amplitude. So A and D. Now the transformations that would have to take place in this case, we have 30 degrees to the right and 3 up. The thing that I want to point out to you is what is called the midline. We don't use it as much in this course, but notice the midline of the graph, the one that cuts that graph in half, is right at 3. Our amplitude is 1, and going down is 1, but right at 3. So the vertical displacement is now the new equation of the midline of it. It normally is at y is equal to 0. If I move the graph up 3, my new graph is at y is equal to 3. Notice what the bottom part of that range is. 3 minus 1. The vertical displacement minus the amplitude. The highest point on this graph is the vertical displacement plus the amplitude. So we can do it graphically or we can do it algebraically. So I would like you to sketch this, please. Again, we are now speaking radian. So turn your calculator to radian mode and hit zoom trade. Before you do anything else, the mode needs to change and our trig needs to change. And then you can punch in your That's a terrible looking graph. That's basically what it is. My midline of my graph is at y is equal to -1. My maximum point is -1 plus 2. My minimum point is -1 minus 2. So, starting with y is equal to 2 cos x. Brooke, what were the two transformations that took place? Pi units left and 1 down. Sorry, that should go up here. had not given you the graph, how could you find the range of that function? Well, that's what I was talking about here. The A value is 2, and the D value is -1. The maximum point is your D value plus your amplitude, and your minimum point is your D value minus your amplitude. Now we can see that the range is from -3 to 1. But if I didn't want to graph that, we can use this concept here. The range will be your vertical displacement minus your amplitude. That's your low point, your minimum. And your maximum is your vertical displacement plus your amplitude. In this case, -1 minus 2, -1 plus 2. As we said, -3 to +1. So you can visually do it. I can quickly sketch that diagram. Oh, I got to go up 2 and I got to go down 2. I don't have to get anything else really right if I'm only asking for the range. By throwing in other things like B and C, it really doesn't matter. The range of this function, without going to your graphing calculator, your minimum point is -3 minus 2. There's your midline. We are going to go down 2 from it, and we are going to go up 2 from it. That's our amplitude. That's how I get my minimum of -5. That does look like a 3. And -3 plus 2 to -1. There is my amplitude. By looking, the amplitude, the range. By looking at that range, are there any x-intercepts to this graph? No, maximum point is -1. This one here, we have a vertical displacement at 4. We're going down a half, our amplitude, and we're going up a half from that point. So my range is 4 minus a half, is 3.5 is my minimum value, and 4.5 is my maximum value. So we are just applying moves to a new graph that has some interesting terminology, but it's still everything that we learned in the transformation unit. Now we just have to apply that to finding domain and range. Well, for range, I should say. Domain is always a real number. How do we find the period of a sinusoidal function? Well, we look at the horizontal stretch. By horizontal, we stretch it by a half. By period is now pi. And that is our 2 pi over p. Okay, so here we are given this equation. What does not look right about this equation before we answer any of these things? It's a very easy level of excellence question that we can work with. This one is factored. The expression was inside the function sign is factored. This one down here is not factored. It doesn't have factored with inside the expression. So if we want to get everything correct, we will get 3 of the 4 transformations correct if we don't factor, but you will get the 4th one wrong. Again, this is because I moved it before I horizontally stretched it. That's what this is where this equation comes from. I do an order differently than we've done our order. So I'm going to factor what's inside here. I'm going to have x minus pi over 3. Now, because by written in this order, we do our RST. We reflect. There's no reflection. We do our stretches. There are 2 stretches. We then move the graph, and there are 2 moves. If you had it in the other order, what happened was they did a vertical stretch, they did a vertical move, a horizontal move, and finally a horizontal stretch. Now, that's not what we're looking at for training here. So, we have a vertical displacement of positive 2. We have an amplitude of 3. All I'm doing, A is your amplitude, D is your vertical displacement. My range, this guy's at 2, going down 3 units, I'm going up 3 units. So my minimum is -1, and my maximum is 5. I happen to like drawing those little things. Helps you remember. Okay, my amplitude is how far off of that vertical displacement line am I? Okay. Period. Well, the 2 tells me I have a vertical stretch by a factor of 1/2. So we can think about it. It was originally 2 pi. I stretched it by a factor of 1/2. It's now pi. Or we can also deal with this equation. So you can do that. I'm hoping that you can, my original was 2 pi. I stretched it by a factor of 1/3. Now it's 2 pi over 3. That type of deal. But that equation also gets you there. And now, because we've done this and written it in that form, we have pi over 3 units. Alexis, do I move it left or right?
Right.
Yeah, you're correct. Because remember, we are always doing y is equal to a f of b x minus c plus d. That guy is always minus a positive number because we have to get bigger. Okay, here we give you a graph. It is easy to get 3 of these, and it's not so easy to get the 4th. And the 4th depends upon your which of the equation sine or cosine you're using. I happen to like this one better, but we can deal with both. So first thing I want to do, I'm going to draw the midline on this graph. I can see that the line y is equal to 2 falls directly between the maximum and the minimum. Therefore, d is equal to 2. So the line, I've taken that graph and I've moved it up 2. I've done some stretches beforehand, but I have moved it up 2. I am going up 2 units and down 2 units from that midline. My amplitude is 2. Now the stretch is a little bit interesting. We first have to find how long it takes to repeat. Well, the nice thing about this guy, we can start here and end there. That's one period that I've sketched. It started at 0 and ended at 2 pi over 3. So I get my period is 2 pi over 3. That does not go into the equation right away. I need to calculate my b value. What type of stretch did I apply to a function that has a period of 2 pi to get a new function with a period of 2 pi divided by 3? I did a horizontal stretch by a factor of 1/3. Okay, you can see that. Started at 2 pi, ended up at 2 pi over 3. More like that. Now, the other way, again, we can use this. 2 pi divided by 3 is equal to 2 pi divided by b. B is equal to 3. We would have had the same thing. We got the same thing if we set a horizontal stretch by a factor of 1/3. We were able to do that. So our b value is 3. Both ways work. I hope you can apply your stretches. What is becoming problematic is what's the horizontal move? The horizontal move depends upon which function we look at. This is the graph of y is equal to sine x. The point we want to look for is what's happening as it crosses the y-axis. Well, that point is crossing the midline. So at the y-axis, we're crossing the midline of that graph going up. So to figure out our move is, where is this graph going up crossing the midline? Well, this is right here. It's going up crossing the midline. So I've taken that point, stretch it, it doesn't move because it's on 0, 0. And then I picked it up and I moved it that way. And I moved it that way of pi over 6 units, halfway between pi over 0 and pi over 3. So our c value, one of the possible answers is pi over 6 units to the right. So we'll just call it positive pi over 6. There are infinite numbers of those, because here's another one going up as it crosses the the midline. Here's another one going up as it crosses the midline. Here's another one over here going up as it crosses the midline. The smallest phase shift is pi over 6 units to the right. I could also say we are going to go pi over 2 units left, and that would be this guy here. Now, both of these equations I'm going to write are perfectly valid for this. We have y is equal to 2 sine 3 x minus pi over 6. Make sure you close your double brackets. Plus 2. I could also write this as 2 sine 3x plus pi over 2 plus 2. And there's as I said, there's an infinite number of graphs, or infinite number of equations that can give me this graph. This here is the one because it has the smallest phase shift on it. Now, the only thing that changes from these only thing that changes from these guys is the amplitude's still not going to change. Still up 2. Still got a midline at 2. So as a period is 2 pi over 3. The only difference is when I ask you for cosine, I find it a little easier to find the point. The cosine graph crosses the y-axis with a peak. So it's easier to find, I find it's easier to find the peak and how far it's being moved over. So here's one peak, and it's pi over 3 units to the right. Here's a second peak over here, pi over 3 units to the left. So my C value is most likely to be written as pi over 3. I could have it as negative pi over 3 also. This would give me an equation. Everything is going to stay the same except for the C value. This is not, well, really, I think when we give you a graph, the hardest thing for you to find is what is the equation of that graph if you are given a move, horizontal move or a phase shift. So you have to, memorize, you have to be able to remember, it has to do with what happens as the graph crosses the y-axis. So, for sine, I'm looking for the point. Where is the point as it crosses the midline? Because the y-axis, and then I'm going to pick it up and move it. So where is that point as it crosses the midline of your graph? So this is the shape for, again, y is equal to sine x. If you're asked for a cosine function, where is the peak? How far is the peak away from the y-axis? Or the nearest peak away from the y-axis? And that's because I'm always using a positive amplitude, not a negative amplitude. Sometimes they do, never seen one thrown on the form, or some textbooks do have a negative amplitude. If you ever do see a negative amplitude, just ignore it, because you flipped it and then you stretch it. So your amplitude is still 3, it's not negative 3, that just has to do with the reflection. Are there any questions on this? There's your homework.
Hello, Ken. You know that PIN stuff that we all went through? They're asking me to use it to log in when my computer locks instead of my full password. Well, it does. So it says PIN to log in, and but that's what's happening is to log in is they're just after I lock my computer to log in with your PIN. Now I don't know if that's every time, but it's happened 2 or 3 times in the last couple of days. So just interesting, not a problem. Okay, bye.
Oh, it's easier, but must be easier to. Well, that's what I think.
You'll have a test with me on Monday, I don't know if it's chemistry or math. And then I'll try to put you probably are gonna have a test every day next week. This biophysics exam next day.
One day. Remember, if it was on Tuesday or Thursday, they might give us a day on next month, remember the 100,000. Yeah, you don't know what it says. Why not? But it's just university.